Hello, good afternoon, everybody. I know it's after lunch, so we'll try to keep it. We'll give some varieties today, so you will not have a single one of us talking during the entire hour. What we are going to do is to have, and by the way, let me start with the introduction, quick intro. My name is Carlos Tagle. I'm responsible for business development for AWS Service Catalog. And we are going to be talking about EMR. And just going quickly through the agenda today, we are going to have a quick overview about EMR. Chris is going to take us through that. Then Jay is going to talk about one of our use cases with Salesforce, how Salesforce is leveraging EMR. And then I'm going to come back and talk about Vanguard and why Service Catalog, it's a good idea when you are deploying and managing EMR clusters. So with that said, and immediately after that, we are going to jump into a lab, into a workshop that we have with that process. So we're following or deploying EMR clusters with AWS Service Catalog. With that said, I will let Chris get us started with the EMR overview.
All right, hi everyone. I'm Chris Chapman, Partner Solution Architect with AWS. We're going to run through some EMR. Is there any people in the room have done anything with EMR or Hadoop? Got a couple? Good. All right. So some of you will know what we're going on about here, and the rest of you will learn something new. Mainly EMR is our clustering service for Amazon. And you can see up there, we're combining a lot of different things into a prepackaged service so that we're all about easy buttons in this setup here. It gives you the ability to use a lot of the tools that you're used to using within that environment. We've got Hadoop probably being the biggest there, and then Jupyter, do some R stuff. And then you've got the whole ecosystem of other partners and open source tools that you can run on top of a clustered environment. So within Amazon and AWS, we have there's a lot of different ways to implement EC2 instances, and one of the biggest cost advantages you can have when you're running a cluster here is to use your spot instances. And this is where the cluster really has a nice advantage because they can come in and out of existence and it's not going to bother you. So as we'll see in a little bit, one of the big links with AWS is using S3 as the back end for your data and also your outputs. And that's what allows these instances to come in and out of existence within this cluster and not invade your data output or get you stopped. So leveraging spot instances is really a good way to reduce the cost when we're talking about big clusters. And if you've ever run out a big cluster, you can quickly spend a lot of money in the EC2 world. We have some very large instances, and you can use the full power of that if you want, but it will also drive up your bill. So the key here, again, kind of the glue that puts it together and allows this distributed computing is the back-end data store, which is S3 in this case. So everything can go back to that. The other unique advantage there is, for your data source, it can be a single S3 bucket, and you can run multiple clusters off of that. So depending on what your workload is, maybe you've got a persistent cluster that's always there and it's always running queries, and maybe you want to spin up some to do some exploratory analyses and just see what's going on, or maybe a new insight team is coming online and they want to hit multiple data stores. So you can, in the AWS ecosystem, that's very nice because it's all localized to AWS. You're not paying the in-out fee to get it in and out of the system, and you can fully use the speed of our network backend and move that data in and out of your cluster. And so that's the EMR-FS, and it just natively shows up inside of your Hadoop system, and you can just call on it directly with the S3 tag, which we'll see here in the workshop in a little bit. When you're setting up a query, you can just say, here's my query, it's in S3, here's my data, it's also in S3, and it's going to move right through the system as if it was a local drive, which is very nice if you've ever tried to set up shared storage on your own. So one of the big ones on EMR is Apache Spark, and with that you can leverage a lot of your classic data science tools. So we've got, for any Python developers in here, that's a favorite one of mine, right? We got some Scala, and then with your SQL querying. So that's the whole thing with the data lake now, is you have distributed data sources, and it might be a database, it might be a group of files. And you want to be able to still give yourself a schematic for what that looks like and how to query it, and give yourself a nice structured query language on top of data that could be in a lot of different places and a lot of different formats. And then there's also Zeppelin if you've got your web-based. So if you want, okay, I've got the cluster, how do I interact with it? So there's some options there. Jupyter Notebooks is another big one, which we're going to explore in the workshops. I'm going to skip through that one. Just showing you the full range of all of the different layers inside of Hadoop that are available to you. If you're familiar with some of these things, EMR is combining them all into that nice service. So then provide you some example scripts of how to bootstrap these in. So you spin up the cluster and then get this software on there. During the workshop, we're going to give you an easy button on how to spin all of this up in one nice little package and pre-install the Jupyter and the Hadoop Hive software onto the cluster, so you can see how that works. And if you want to use MXNet instead, you can install that and use the cluster in that regard. And then back to the S3 thing, that really provides you that transparent data source to extend the cluster's ability to come in and out. The instances themselves can be very ephemeral. None of the data should be stored there. You're moving it all back. You're moving it from S3 and you're moving it back to S3 as your output. And then you can consume it with different with other services. If you wanted to do some reporting, pass it right off into insights from there. I'm going to hop through these guys here. So I like this one here with the EMR automation. If you've ever stood up your own Hadoop cluster, you know that there's a lot of moving parts to it. And that's really the advantage of, with EMR on AWS, is having that ability to very quickly get this cluster up and running without needing to worry about all these individual pieces. It brings you into a VPC. The networking's already done. The security between the master and the nodes is already there for you. And it gives you a nice little URL at the end of it to, here's your access point into it. Yes, sir. Yeah, you can use spot instances for it.
The spot EMR variable instance name, and it based on spot availability goes up and down. And
correct, yes.
Swaps from S3 to the memory and back and forth.
Yeah, so then, and that's the key to it, is that, so the question was how the spot instances, because they're coming in and out of existence potentially. And that's the key, is that your data is being output and consumed from S3. So, and also that's where your queries are going to originate as well. So because of that, the individual nodes, it doesn't matter how long they live. They can come in and out of existence. Depending on your workload, you might need to stick with some on-demand instances in order to maintain a certain level of, where are actually, you wouldn't want your whole cluster to be able to shut down and go out of existence. And certainly like the master node, that would not be a good candidate for a spot instance. It's really up to you on the workload, because like anything, when we're talking about big cluster systems like this, you've got, on one hand, you've got the cost, right? And then on the other hand, you have the speed at which you want to run the queries. So if you're trying to do real-time analytics off of, like we just saw on the streaming stuff, the speed might be far more important to you than the cost. And then in other times, simple little exploratory thing, maybe you want to go with smaller instances, and it could run all weekend as long as you have the result at some point. And then you come back, come back into the office on Monday, and in your S3 bucket, you've got your output. So that's the nice thing about it is, we leave that up to you to balance those factors, and you can make that decision on where you stand on that, that spectrum. Yeah, and then, so the other thing is back to the, why EMR and the automation of all this. So Hadoop is one thing, getting it stood up is one thing. You've got all the networking, all those pieces involved, right? And then the next question is, how do I use it? How do I interact with it? How do I, send queries to it? And where do I get that data back from? And that's the other thing that we're providing within the EMR service is the ability to quickly get into there and do that. So when you're talking about your data scientist role, they don't need to worry about what a VPC is or a security group or how the KMS is encrypting your S3 bucket. It's spun up, it's handled, and then they have a direct portal into how you're going to submit those queries. And we'll see in the interface there's you can even do steps right through the UI. So you can template those, or you can go and manually do them in the console. Yes, sir.
You said the S3 is the storage layer, it swaps in and out.
Yeah.
In case of streaming, is it goes to both memory as well as S3, or it always goes to S3 and then?
Oh yeah, so you could if you're going to do a stream, you would handle that stream as the input. So the input doesn't necessarily have to be S3. You can query things out of databases, streams. Foreign sources that I don't even know about. How you get the data is just up to what is available within the package in Hadoop or Spark or whatever you're using to get there. But the output and the state of whatever you're running, that's where S3 manages that, and that's the consistent layer that always exists and does not come in and out. It's non-ephemeral, yeah. And then you can even, the whole power of S3 is we can move that around to different regions. You can set up the encryption and all that stuff. So you have a lot of power in protecting your data and making sure that it doesn't get lost in that regard. Nope, wrong laptop. Nope. No, we already did. Yeah. Yeah, so this is a reiteration there, and just showing you the different tools and how you can set things up. Maybe you've got a couple different instances, and you're reading, your CloudFront logs, for example. That's what we're going to work with in the workshop. So you want to do some analytics on your websites, and you want to do maybe you got a couple different teams. You've got a couple different purposes behind that. We can spin those up, purpose-built clusters. And they're all hitting that same data. They can consume that data from the same spot. They can drop it off in the same spot, or they can drop it off in different locations. So you could have sensitive information that only one team has access to. We can consume that generic bucket, the public bucket, generate that data, and then drop it off in a more secured S3 bucket if we'd like to do that, and really leverage the security of IAM and S3 on your long-term data storage there. And then on top of it, since it is running on EC2, we have the full ability within EC2 of all those different instances that are available to you. So if you're running a very high memory workload, we've got high memory instances. You're running something maybe in TensorFlow or something like that. We got GPU instances for you. Maybe it's not memory driven at all. Maybe it's all CPU driven. So then we've got the high CPU instances, and we can leverage all of those. You can really, the goal there would be to match the demand of your model to the resources in EC2, and you're trying to maximize cost by doing that. So if you have a high CPU instance, we can go with the higher, high CPU usage, go with the high CPU instance. Maybe that gets you back a little bit faster, but you're not paying for all of that RAM. So those are options that you can consider when you're bringing this up to really seek that cost maximization. Yes, sir?
Do you have any recommended templates depending on the data science workload?
We've got a couple. So in the quick starts, we've got some, and then we're going to work through one in the workshop. But In general, that's kind of left up to you because it's hard for us to predict what your model is and what your data is doing. So if it's if you're bringing in something really fast, you're going to want the ability to handle those high CPU loads. Or if it's just a very large data set and it's not doing a lot of math, then we could go with just a high RAM instance. And that's kind of our idea there, is to provide you the building blocks to build whatever it is specific to your situation. Yeah.
But templates would be nice for exploring how compatible your workload is relative to.
Yeah. Yeah.
I don't have to spin around and waste a lot of dollars trying to figure out the best match.
Right, yeah. So the question was, having some templates in order to try out your model across some different infrastructure. And yeah, that's something we can I can show you during the workshop. We're going to go through, and there will be a template, and I'll walk you through all the pieces of that so you can see where that's at. And that's another thing. Later we're talking about Service Catalog. And Service Catalog will bundle this into the easy button, right? So it gives you the cluster and it gives your end users just that launch button. So what you could do is we could generate a template that has a couple different instance types in there: high memory, high CPU, low memory, high CPU. Give you some flexibility there, and then put that in a drop down. So your end users would be able to select that. Since the model and the data is in S3, or wherever it is, it's in some other source that's static, you could then run your query in each one of those different environments, and you haven't spent a lot of time getting them up. It's all based off of that launch button and then what you selected in there. So you could provide that flexibility to your users, and we'll walk through that here in a little bit. Yeah. Yeah, and that's what, that's the other side of this is, it's one thing to be able to get it up and running fast, and then also your scalability within EMR is very nice. If you've set up Hadoop, it's, when you set something up like that and then it's running and it's doing its job, that's great. But what happens with all those other hours when there's nothing going on, right? So we want to be able to, again, it's about maximizing that cost function. We want to match our usage to our instances. So you leave that master node running, but you can scale up the worker nodes as needed, and with different instances even. Yes, sir.
All of the scaling here is just leveraging on top of all of the EC2 stuff.
Correct. Yes. Yeah, except we've packaged it into the service, so it's a little bit easier to generate that auto scaling group. Yeah, it's a more purpose-driven group setup. Yeah, and then you can mix and match. You can have you can have some nodes that are high GPU, high memory, and others that are maybe some of the more basic nodes, EC2 instances. Sorry. Yeah, and here's that's what I was just saying here, where you leave the master node running, and then you can move those individual the parts of the cluster around as needed to depending on your workload, what you're doing at that moment in time. And some of these workloads might be static, and this isn't really terribly beneficial to those workloads. But other workloads where maybe it's a report that runs once a night, twice a week, once a month, then you don't need to spend the money constantly on the EC2 instances, where you can just scale with it and do those more on demand. And then on top of it all, the cluster itself, like we were saying with the spot instances earlier, the cluster itself can go in and out. It can be ephemeral on each individual node, so it can tolerate losses, it can tolerate drops, and that's what allows you to leverage the spot instances when you're looking at your cost maximizations. And with that, that's pretty much EMR. So yes, sir.
Do you have a standby master node in case the master node fails?
So you would want to leverage the EC2 auto scaling for that, and just what you could do is if you just needed one master node, you would create an auto scaling group of one, and then if it does go offline, it'll come back on. That would probably be the best way to do that. Yeah.
So everything is on hold until it comes back up?
You wouldn't have access to it. Yeah. Yeah. Yeah, well, it depends on what. Yeah, it depends on what kind of load and what kind of model you're running. Yeah, so losing your master node would probably, in general, be a bad situation. Cool. I'll pass it off.
Thank you, Chris. My name is Jay Menon, and I am a senior solutions architect with the strategic accounts. And I'm here to talk about Salesforce DMP. But before I start talking about Salesforce or EMR, how many in this room really know what a DMP is? OK, one. Yes, data management platform. How many times have you experienced this, that you're browsing or you are on Instagram or Facebook, and all of a sudden one of the ad pops up, which is somewhere related to what you were searching before at Amazon or something? Does that happen often? That's what DMP does. So a data management platform is really good at doing what most brands really care about, which is identifying the audience and basically offering a personalized experience to the users who matter the most to these brands. And that's exactly what Salesforce DMP also focuses on. So before Salesforce acquired this platform, the name of the company was Crux. And I believe in 2016, Salesforce acquired Crux and renamed that to Salesforce DMP. And now Salesforce DMP is a part of the Marketing Cloud segment of Salesforce, and supports a variety of customers. As you can see from 2017, and I think this is a little bit dated slide in the sense that it captures only the names of customers that are since, I think, mid or late 2018, pretty much. But we are talking about fairly large-scale customers here, and to support this kind of customer base, Salesforce DMP just by itself holds about 40 petabytes of data. And the last time I met one of the founding members of Salesforce DMP, he was telling me that they are expecting it to go twice by April 2019. So I hope that we should be somewhere in the range of about 80 petabytes of data that the DMP platform is processing on a regular basis to actually provide the right insight that these brands really care about. And just to give some more perspective on the scale side, here's a 60-second snapshot of what Salesforce DMP really process, right? About 4.3 million user match requests. And if you just compare it with the number of Twitter feeds, Twitter claims that they process approximately 350,000 feeds per minute. So here in DMP, the last I checked, it was about 200,000 query per second that they process. So you can imagine the kind of compute and the processing requirement that DMP holds to actually satisfy the needs of these large-scale brands that they are supporting. And to support that, we are talking about roughly 3,000 EMR clusters that they spin up. About 100 I remember the last one was about 120,000 compute instances attached to these EMR clusters that is actually generating all the insight that these brands are asking for. So when you're operating at this scale, like what Chris was alluding earlier, one of the key things to keep in mind is how do you actually make it a viable product from a cost perspective? Because yes, cloud computing gives you all the bells and whistles to actually identify the right information from petabytes and petabytes of data. But churning that petabytes of data requires a lot of compute and a lot of storage. How do you keep that cost low? And that's where, like Chris was saying, Spot instances makes a lot more sense. How many of you really know what a Spot instance is here? OK, quite a few. So I'm not going to go too deep, but just a one-liner statement. A Spot instance really provide, think about it as unused capacity in AWS data centers. We offer to you as Spot instances at substantially reduced cost. So usually Spot instances can actually help you save cost up to 90% as compared to on-demand instances. And if you have your product written in such a way where you have the right checkpoints and retries implemented in the right place, you can effectively use Spot instances to substantially reduce the overall cost, which is exactly what Salesforce DMP do in their case. If I remember correctly, the last number that I got from them was, apart from their master nodes, they pretty much rely their entire EMR clusters leverage a Spot. So you can imagine the amount of savings that they are making from this. A couple of other things while we are talking about Spot is Salesforce DMP also effectively make use of Spot Fleet. How many of you know what a Spot Fleet is? It's a feature in Spot. Yeah, so what Spot Fleet offer is, as a user, if you're using Spot, you can go to Amazon and say, I need C4 large instances, or you can give me an M4 large instance, or R4 instance family. And that's all I care about. Figure out how to get it. I don't care which availability zone you are giving it on. I don't care how many numbers is it going to be. I will just give the bare minimum configuration that I need. And Amazon Spot Fleet will automatically go and crawl all its data center availability zone regions and figure out what's the right capacity, is it available at the right cost, and at what point you should be actually be getting those number of instances. And this will allow you to kind of automate the orchestration process in a very effective manner. The second feature, which is also very useful while you are using Spot, especially with EMR, is a Spot Advisor. Spot Advisor actually gives you a lot of information about how many Spot instances are available in specific region, or the probability of you securing Spot instances when you request. What is the probability that it will be available for you for the duration of your use? So typically when you secure a Spot instance, there is a possibility that someone might come and bid more amount of dollars on that, and you might lose that particular instance. So Spot Advisor have the artificial intelligence built in to basically let you know how long you potentially can have a particular Spot instance. So if your job takes, let's say, 2 hours, you can actually look at the Spot Advisor and understand if the nodes that you're getting, the instances that you're getting, will be available for the duration of that task, which is very useful when you're actually operating at this large scale, because using that information, you can create more orchestration layers, which will selectively pick those instances that is available for you for the duration of your work. So that's something that Salesforce DMP use very effectively in their use case. And here's a high overview of how Salesforce DMP works. So on the left side, as you can see, all the data is getting aggregated in S3, and these are the data that the end users of these brands. So for example, if you're a customer of Adidas and you're going and browsing shoes, that all the different areas, the clickstream data on website, or if you're using a cell phone, or you just did a Google search, for example, of Adidas shoes, all that data is captured and stored in S3, which is what Salesforce DMP use as their primary data lake. Once that is done, this particular slide really talks about the on-demand segmentation. And just to give you an overview, segmentation is the process where you are streamlining or narrowing down the data to a specific user, all the way from anonymous data that is available, which may not even recognize a user. So imagine you are logged into Facebook and you're searching for Adidas, or you clicked on an ad on Adidas. Salesforce DMP have a mechanism to actually capture that particular data and store it in their data lake, which is S3. Salesforce customers are offered a console in Salesforce DMP using which they can define specific rules. These rules allow them to specifically categorize the data into segments. So for example, a rule could be customers who are making a search for sneakers. And that might be interesting for a specific brand, and one of their configuration admins will go and create that rule. And that gets stored in the RDS system. And an EMR cluster will spin up. It will take all those rules stored in that RDS, which is our relational data store offered by Amazon, and process all the data that is stored in the Salesforce DMP's S3 data lake against that rule, and create valuable insights. So 2 parts of this is there is an Einstein segmentation, which is Salesforce's homegrown artificial intelligence. So of course, as human beings, we can define certain criteria, characteristics based on which we can segment a user. But at the same time, there are hundreds of criteria and characteristics based on which you can segment users. And that's where the Einstein platform segmentation also come in. So it's a combination of the Einstein segmentation combined with the rules that manually created. That's being processed by the EMR system. And finally, it will create valuable insight that is either shared with partners or it is available for the marketing firm so that they can do targeted ads. Yes.
The S3 side, is it immutable when you do aggregation, you load it to the EMR, or do you do daily reconciliation aggregation in S3 itself and create a placeholder for it to load the EMR?
Yeah, hold that question for a second. Probably the next slide will address that. So what I presented in the previous slide was more of a logical way of looking at it. This is more of a componentized architecture view, which will probably address your question. So as you can see on the left side, you have data coming into S3 from various different data sources, log files, CRMs, pages that end users are actually going and visiting, which is usually the clickstream data, so to speak. And then all the data comes to S3, and then it gets picked up by EMR. So going back to your question, is it a batch processing, or is it happening in real time? Well, the bottom side of that left side, which is Kafka streaming, that's processing it in real time. So you are actually supplying all that data to Kafka. Kafka takes that data from all these different sources, stream it to Spark streaming, and then in near real time, it is getting processed and distributed to the partners' ecosystem by the Salesforce DMP. There is another set of data, which is also periodically processed, which is the center portion of this, where most of the data science and batch processing is done. And this is taken care based on the previous slide that I was talking about, where the Einstein analytics and the configuration, the rule configurator comes into picture. So this particular center section and the on-demand segmentation is actually using a combination of manually defined rules to segment data, as well as artificially created rules by the Einstein platform to segment all that data and then create insight. Did that answer?
No, that part is clear. CRM data is changing every day or
Correct.
every hour.
Uh-huh.
Right? How does your S3 consolidation happen? If it happens in S3 itself, reconciliation and consolidation, because you might have done 10 number of activities every time the 11th activity or another minute. So
Yeah.
if the consolidation happens in S3 itself, and how do you condition that? Do you update, or how do you keep it up and that information is propagated for data processing? Do you do aggregation, or do you just do immutable transaction data, and then you take that and do aggregation on the fly data processing?
So the aggregation is done on the flight, actually. Yes, correct.
S3 just to store only at the transaction level.
That is correct. And there are, depending on the use case, right? So if there are reporting and specific, again, like batch processing use cases, it may be actually holding the data as a persistent layer for a prolonged period of time before it actually picks up. But by and large, the use case that you are talking about does not really require it to be used as a kind of data lake, so to speak.
Yeah.
Right.
Consolidation or aggregation happens after this, because otherwise it's complex.
Yep.
Because it's changing every time you don't have a destination. Either you have to wipe out and recreate the destination in S3,
Uh-huh.
you need to change the destination, but aggregation is changing.
Correct. So if you look at the overall how Salesforce DMP work, there are all the three different kinds of use cases: real time, aggregate, batch processing, and as well as like use it as a kind of transactional store. And all that has been handled in this use case. That's why I kind of presented this one, because it kind of opens up all the different aspects. So that's pretty much about the architecture of how Salesforce DMP is leveraging EMR for, yes?
What does MRT stand for?
Near time, real time. So some of the key learnings from here. From a compute side, if you are leveraging Spot instances, make sure that you don't really statically map to AZs, because different availability zones have different capacity, and that keep varying. So if you just statically map to one particular AZ, there is a possibility that you may not have the capacity that you need. So keep that flexibility in your architecture whenever you're designing it. Similarly, the instance types and families, the more instance type and family you have in your Spot fleet configuration, the more possibility you will have the availability of instances when you need it, instead of waiting for the right configuration. That's one. obviously, do not spend too much money on, especially when you're thinking about EMR, don't spend too much money in IO1 and higher level SLA-based disk capacity, because you are pretty much focusing on the immutable pattern here. You process data, you throw it away. You do not want to invest a lot of money in creating a data store that is going to be long-lived and provide a huge SLA. Most of these workloads are also by nature designed to actually recover and reprocess if there is any failure. So the chances of you losing significant amount of data just because, let's say, EBS volume got stuck or something like that is very, very minimal. So build that ground up when you're thinking about this architecture from day one. From a storage perspective, obviously, like have a data lake strategy depending on your use case. In this use case, it's kind of fairly complicated, as you can imagine. There is streaming, there is a fair amount of batch processing happening here. It makes sense for you to actually gather the data in a very fast mode, in an unstructured way, and then have some kind of data lake technology that will help you do the cleansing part in a staggered manner, right? So lake formation is something that we recently introduced. So take a look at that if it makes sense for you. Compression, another thing, like data transfer, when you're operating at the scale of 100,000 or 150,000 nodes or 3,000 clusters, the data transfer between clusters can actually cost a lot. So you may not come across on day one as a significant contributor to the cost, but when you're operating at that scale, keep in mind that it adds up. So think about compression technologies. DMP very effectively use Snappy and also. So that's something to keep in mind. Lifecycle policies in S3, I hope most of you are aware of that. You can actually configure lifecycle policies in S3 so that objects can be expired, or it can be moved to less expensive storage platforms after a certain duration, and that will substantially reduce your overall operational cost when it comes to S3. And then there is also a S3 intelligent tiering, which we recently introduced, which automatically applies some kind of artificial intelligence to figure out, okay, you have not used this file for, I don't know, X number of days, so it does make sense for me to automatically move it to a low-cost storage medium within AWS. So take a look at these features, very critical when you're trying to operate EMR at this scale. Similarly, to have good visibility and control over cost, use tagging very, very effectively. This is not necessarily an EMR-specific recommendation, but in general, if you are in AWS and if you're using EC2, tagging goes a long way if you are effectively implementing it from day one, because you can specifically categorize cost based on tags. So you can even create an EMR cluster for a customer and tag it based on, let's say, customer name, and your cost, your reports will clearly articulate how much did it cost to you to support that customer, for example. CloudWatch alerts, very important. You do want to aggregate all the logs, make sure that all the monitoring metrics are aggregated in a central place. Most of the Salesforce team really leverage either commercial off-the-shelf applications or our Elasticsearch-based log aggregation tools to aggregate all the logs. So it's easy to actually monitor and manage one EMR cluster. When you have 3,000, you might want to have orchestration available to aggregate logs and monitor it centrally. So these are some of the lessons learned. I'll let you take over. Thank you, Vanguard. Thank you.
Thank you. So just to get us grounded, in some cases, and I had customers asking me, well, it's great that you are showing me those examples of high volume and how to manage those, but I may not have that kind of volume. But the lessons from here, and that's the reason why we are bringing these points here, is that not everything for sure will apply to you, but some of these lessons will help you to form, even when you are doing this at a different scale. So that's the reason of touching in these two use cases, in particularly Salesforce. And now, talking about Vanguard, which we are dividing it in three different sections. One of them is just the overview of how they got into it, how they started. Then the second section is a brief overview of what Service Catalog is. and then what is the evolution or how they leverage that. So just as a quick reference, maybe some of you are users or are familiar with Vanguard, but it's a very large firm, financial services, mainly on the investment side. They have a set of EFTs, and obviously they have a number of use cases that have to do with big data. They are in the space, they are not that old compared with other financial organizations. As you can see, they got established in '75, East Coast. But they have very interesting cases, especially when it comes to data scientists. They have this philosophy of self-service, ensuring that automation and self-service, it's in the front of everything they do for data science. So I will be showing this series of diagrams here. I know it may sound a little bit repetitive in the beginning, but it's helping us to start from the highest level of how their data lake works, and then taking it down. So what you can see, it's what normally will happen with many organizations. You will have some on-premise sources, you will have vendors and third parties, and then you will have the data lake or getting the sources ingested into S3. You will have different lines of businesses organizing those S3 buckets inside AWS, and then they will be running EMR clusters to get into to organize and ingest that data. So they transform, and analyze the information. So as we have been talking across the presentation, EMR helps you with this ephemeral feature. So you don't want to have the clusters running all the time. So if you are ingesting data, if you are bringing it, you process it, you bring it, you leave it in S3, and that's exactly what Vanguard is doing here. So they are more transient. Now, if we go one layer down into what this is, it's when we bring the data into S3, or when Vanguard does that, they create a raw layer, just to call it somehow. What they do is they have a cleanup process. This cleanup will have, depending on the usage, a set of rules, and then they will use EMR clusters, and they will have something that they call analytics ready. They will have this set of S3 buckets that are ready to be consumed by data scientists. Now, in general, you want to have data for the general audience, but there will be some data scientists that want to get access to the raw data. So that's why they divide it and they give access. What they were telling us is that a very high percentage of them, probably over 80%, will be consuming the clean data, and only few or a smaller percentage will be getting access to the raw data. That's a design that it has worked for them, especially for the different applications. Now, how the pipeline works, and especially this is the previous state, and this is the first section that I was talking about. This is how they started doing it. They use third-party tools. This is not an AWS tool called Bamboo. It's a CI/CD, continuous integration, continuous delivery tool that will help with the automation and will help to create or store this code into the CF using S3. They will have the CFN. They will have the JSON files, they will have Ansible, they will have YAML in there. So that code gets stored there, and Bamboo will be executing it. And that's important because everything you do, and again, going back to the scale, you may not start with the scale of Salesforce or Vanguard, but when you are creating something in the cloud, you want to take advantage of the scale since the get-go. And that's what they were looking to do precisely here. Then they have another tool, another third-party tool. It's called Control-M, which is a scheduling application, which will create a load balancer inside AWS and will spin up an EC2 instance and any other infrastructure that they need. Again, they keep automating into that. They They bring vendor or vendor-related sources as well into the data lake. In some cases, they spin up a temporary FTP server. Again, keeping the automation. Everything here is moving along the same theme. By the way, another good practice they have there is that they have their own set of keys. So everything they have, it's encrypted. Every S3 bucket they have is encrypted. And by the way, they have their own keys. That's why you see the KMS keys there. And obviously, the data in transit is encrypted as well, another best practice of security. Another way of bringing it up as well is to create the FTP temporary servers I was talking about. And another way of bringing the database, whole database sources, is to scoop them into S3 and use Hive tables to store the data. So again, this is a general theme in which you will be seeing the automation they are bringing into the picture and making sure everything they ingest, these data pipelines, get integrated into their tool set, and they don't have manual intervention, or they get repeatable patterns in making that happen. So the same happened with analytics. This is another set of slides that will talk about that. Same kind of tool, Bamboo, doing the scripting based on S3 buckets, Control-M spinning up an EMR cluster. You see the same tendency going out here. And then they will have enabling Huey as a source in which they can expose to the end users. Something they do in particular, they have Tableau. So they support other tools that will reside in EMR. In this case, they have a Tableau instance or server, Tableau server inside AWS, and using Presto, they are getting or exposing that to end users. So in general, when you take a look at this, or their first approach, when they finish, they felt very good about that. They felt about the deployment, and this is a continuation of that on how the cluster deployment happens when they create EMR. All the IT teams will use another set of tools, Bitbucket. They will use Bamboo as well, and they will have an automatic way of creating it. Yes, going back to the previous slide. Yes. Presto is just the layer that will use that will share Tableau into the end user. To be honest, I'm not very familiar with Presto, but from what I understand, it's a third-party tool as well. It's not an AWS tool, but they use it to expose the Tableau server and link it into the end users and give access to that section there. Yes. So it is an in-memory superledger. Yeah. Yeah. Okay. Yeah, and they use it only to move or to share that Tableau section over there. So it's not that they use it for other processing inside this scheme here. There is another question. Oh, just to repeat repeating the question here, it was if we were using Presto into this architecture, or Vanguard was using this as part of the overall architecture, and the quick answer is no. It's just making it making use of that for the Tableau exposure to users. So what could be improved from this scheme? It's highly automated, leveraging a lot of AWS and non-AWS services. So what they came up with is that they were very successful. They were deploying many EMR clusters along the environment. They had some of these numbers here, over 150 engineers that needed to have access. That included engineers, data scientists, and other personas getting access to create EMR clusters. They had over 250 EMR clusters spin up every day. That means that some of them will be running for longer, but at least 200 and plus running continuously at different points in time. They had over 100 data stores and about 1 petabyte of information, which again, it's a great outcome. Everybody was happy. Yeah, we are growing. The main challenge they saw with that is how do we scale? How do we provide these kind of templates and automation to the rest of the organization? And that's why we started to work with them on what were the goals that needed to be achieved, and especially attend the demand for increased analytics, making sure we can enable compute faster, and having the operational resiliency and the environment that needed to be available around the clock, and self-management of self-compute. In other words, data scientists and other IT engineers, you wanted them to have the ability to spin on and spin off any of the services, any of the EMR clusters. So in order to do that, what we work with them, and let me just do a quick round. How many of you have you heard or have you worked with AWS Service Catalog? Okay. I got one hand, so at least it's one better than none. So the AWS Service Catalog, it's a service that has been out for about 3 years. And it has been, it's one of the management tools we have in our portfolio. But for whatever reason, it hasn't had probably the visibility or the adoption we wanted to have in the beginning. But that's changing precisely thanks to cases like this. What it does, it's pretty much enabling self-service. It's bringing the tension between two different worlds. One of them is the consumers of services on one hand, in this case, data scientists. And on the other hand, the people who need to control and manage the environment across the different cloud and non-cloud environments, mainly infrastructure teams, governance teams, even finance teams. Because with the cloud, you can spin off an entire data center, but if you don't do it with the right parameters, with the right guardrails, that could become a challenge. So if you go today, and I was asking the question just to see if I will stop in these slides a little bit more, so I will spend a couple of minutes here. If you go today to the AWS console, what it happens is that you can either have access to a service, or you will not have access to the service. And that will happen with EMR, will happen with EC2, will happen with any of our different services. Now, if you have this variety of choices, somebody getting into the console, like a data scientist, if you give them direct access to some of these things, they will get lost, or they will invest cycles that you don't want them to invest to spin off services like BI services in this case. So what we do is we define infrastructure as code. Basically, any CloudFormation template, Terraform, you package those, you create something that we call a product, and that product gets into a portfolio. A portfolio, you can think about that like a folder. It's a set of different products that a particular set of users will have access to. So a quick example, it will be this EMR cluster. So you can create a product in which a data scientist will have access to launch an EMR cluster, but it will not have access to the underlying service. So if they go to the console, they go to the EMR, and they try to spin it off, they will not have those permissions. But if they get into AWS Service Catalog, and they will have an infrastructure as code template or a CloudFormation template, basically a YAML file that will define what kind of cluster they will launch, then they can do that. So that's the main difference. It helps for self-service, and it's the integration point for many platforms, including ITSM and other DevOps tools. So now that, and these are some of the concepts that I was talking about before, you have a group of people that will create the templates, you will have, which are the people in the top of this slide, the service catalog administrators, and then you will have a set of consumers that they don't need to know what infrastructure as code is. They don't need to know how the sausage is done. They just need to consume it, and they will pick from the authorized list of items to launch and manage those services. So here, what I'm trying to relate in this slide is that we are this gateway to AWS services. It could be EMR, it could be EC2, it could be a stream, and all these different tools, including Bamboo, which is the one I was talking about with Vanguard. ServiceNow is another of our integration points. Very different tool. It's an ITSM tool, but we serve as an integration point because it enables that self-service, and you can leverage any workflow that you have there. Ansible, we have integration with Marketplace and other AWS services, Chef, and an integration or a reference architecture with Terraform. So how is this relating to Vanguard? And this is where the parenthesis ends about AWS Service Catalog. Here is what they did, what they decided to do after realizing that what they were doing, it was highly automated, but it was not easy to scale, is they have a group that is creating the portfolios. As I was saying a few minutes ago, a portfolio is nothing else than a group of CloudFormation templates, a group of scripts that will define what kind of EMR clusters and the characteristics of it, and some parameters predefined or pre-authorized. Then they will have another group that will put the templates or put the baselines. And normally those will be the security groups, will be the infrastructure groups. They will have the right tagging as well, making sure that from the cost perspective and project perspective, they identify those workloads. And then you will have a third group, which will be doing the customization. Now, again, going back to the example, this is a very large organization. You may think, well, that's not how I'm going to get started. But those three functions could get part of a smaller scale. If you are going to start doing this from the scratch, then you most likely are going to replicate how you are creating EMR clusters. So if you are doing that anyway, you are scripting it in some way, it's better just to put it in a repository that you can later distribute and leverage, even if you are not doing it as part of three different groups as they are doing it at this point. And in this way, what they are expecting is that you will have the pre-authorized templates, you will have the pre-authorized kind of EMR clusters make available for the different data scientists. They will pick a set of parameters. They could be number of clusters, they could be VPC, any of the parameters that you will typically get in a CloudFormation template or infrastructure as code. And then you will have the authorization to spin those off. So what they are gaining by this, it's the confirmation of what they were asking us in the beginning, making sure they have quick access to the deployments and they can access faster, especially now because you are predefining the parameters. We were talking, Jay was talking about using different availability zones and be careful about spot instances and those kind of things that could get tricky. Now they could become part of the standard. Now we can say, hey, this is the standard that you are going to follow. This is scripted, this is repeatable, and then you can continue deploying that with that confidence. And one of the biggest things as well that they were asking us is, how do you integrate with workflow tools? In this case, they are using ServiceNow. So if they want to authorize something, they already have a workflow in which they are authorizing a data scientist or a project to spin off some workloads. They want to build the automation after that. So Service Catalog brings that integration point. So after all the approvals have been done, Service Catalog will do the deployment and the management. So users will stay in ServiceNow. They will not even need to get into the AWS console and do all the management of those clusters directly in that platform. And we have other integrations that we work like that, and especially based on customer feedback. We have another integration with BMC, Helix, and Digital Workplace. So this is in summary, this is the the three sections. What we wanted to show today, it's precisely an overview of EMR, a couple of the extra use cases, and show you why, as part of this lab, we are going to be using AWS Service Catalog to deploy EMR. We believe it's part of the best practice because it's what we have seen with customers that scale, and even some other customers that have much lower scale, but we can see many more lessons learned in somebody who's using the platforms at a higher volume. So with that said, if there are no other questions, we can jump to the lab. Thank you. Do you want to?